All right, everybody. Hope everybody got that check-in did. So, here's our check-in. Did everybody like being on a boat?
Yeah.
Do you like being on boats? You like being on boats? Big boats or small boats?
Big.
Big boats? Small boats? I'm all about small boats. I don't know about big boats.
I like cruise boats.
Big boats are so big. No. Cruise boats are for COVID.
Before COVID. Before that even.
Anyway, so you were on a boat. Boat's motion described, blah, blah, blah. Which word best describes? Well, it's flat. It's constant, right? No. Remember, you got to read this left side. It says that's the acceleration. So the acceleration is constant. Acceleration is 2.5, and it's 2.5, and it's still 2.5. But what does it mean when if something's accelerating at 2.5? What's that mean that it's doing? The acceleration is constant, but what's the object itself doing? What's happening to the object if it's accelerating? Its velocity is increasing, and that's what it's asking about. It's not asking about acceleration. It's asking about velocity. I know we've seen this question before, but make sure everybody gets this sort of concept for the CTBEA. When it's accelerating, the velocity is increasing. All right, so today we're doing a lab. By the way, everybody in the studio audience land, I'm wearing my boxing mittens today because it's gloves/mittens day for theme days as far as December goes for the faculty. So we have December theme days for some reason. I don't need that. Well, today we are doing a lab. That's why you got these boxes out here, these black boxes. So we're going to calculate our, let me see, I gotta see what I look like over here. When I stand up here, yeah, nobody can see me. Hi. No, whatever. All right, we're doing a lab, and in this lab, we're gonna calculate our power. That's a whole new thing. So we did potential energy and kinetic energy and work, and now we're doing power. So to figure out what power is, you may have already looked at the lab. I've got it up here. How would you describe a more powerful car versus a less powerful car? How are they different?
Horsepower?
Yeah, horsepower is a measure of power. It's not what we're going to use because that's the imperial unit. Horsepower isn't even an imperial unit. It's something completely different. It's a little silly with the horses. But yeah, how's a less powerful car different? So I mean, yeah, it's horsepower rating, but that just tells you if it's powerful or not. So what can it do different?
Go faster?
I mean, it can go 60 miles an hour, and so can a less powerful car. I mean, I guess if you're saying,
Like
it takes
get there faster.
yeah, you can get to 60 faster, right? So, and it's not about how much energy it has, because if they might have the same amount, they can have the same amount of kinetic energy at 60, and they can have the same amount of potential energy if they have the same size gas tank, because that's where their chemical potential energy is. They're burning. Yeah, make sure your noses are covered, everybody. It's about how fast they get there. So if your car can spend energy fast, then it's powerful. Like if it can spend a lot of energy and get to 60 in 5 seconds rather than 6 seconds, then it's a more powerful car than the other car. It's about how many joules per second you spend, and that's what the unit for power is called. Well, not really. We don't say joules per second. They made up a real a shortcut word for power that you might already know. Would anybody like to guess what the unit for power is?
P.
What?
P.
That's the variable. That's the variable. And don't look at the board here. I don't know if you can see this. Anybody else? Jada, what do you think? What's the unit for power? It's the same unit that you're what?
I don't know.
Oh,
Joules?
this is what?
Joules?
No. What? Oh, no, sorry. I couldn't tell who was talking. Same unit your power company uses. Watts. That's right. Did you get it? I was asking everybody watt. Oh, that's one of my favorite things to do all year, is the watt thing. So yeah, power is measured in watts, and that's just a shortcut unit. It means it's joules per second, and joules are really meters, or what kilograms meter squared per second squared. So joules per second are really kilogram meter squared per second cubed, and that's what watts are. But let's just call it joules and watts, and then we're good. So yeah, in your lab, you're going to estimate your weight in pounds, and then what's it say? Multiply that by 0.454, and if you don't want to share your weight with or your mass that you're going to convert to with the form, then you can make something up, and that's fine as long as there's something there. So find your mass, and you're going to step up on the thing. Let's see, do I have something I can step up on as an example? I got this thing over here. So these black boxes are just like a foot and a half tall or something like that. Now, when you measure them, please measure them in meters. Remember, if you got 32 centimeters, that's 0.32 meters. So I have more potential energy now. I just gave myself some joules. And I can time how fast my joules per second output was if I time myself doing this. So if I say start, stop. Now I can estimate my mass. I can measure the height of this box, and I can use MGH, where G is 9.81, negative 9.81. And remember, make your H negative so your energy turns out positive. I can use MGH to find out how much energy I just spent, and if I time myself, start, stop, then I can figure out my power. I can take that potential energy divided by how long it took me. Now, please don't try to find your maximum power here. I don't want, that could cause a safety concern. If I try to get up here really fast, I might tip this over or something like that, and don't do that. So we're just going to find out how much power you do when you're doing it carefully, all right? I think the European cars actually use watts instead of horsepower or anything else. I know they use Newton meters for torque, which is pretty cool. Instead of foot pounds. Pound feet. Anyway, it's going to ask you to do it twice. If you have time, please make sure you do it twice. I just made those two optional just in case some people took really long, but I think y'all are going to have time to do one height and then do another height. I don't recommend standing on a chair or anything else that'll tip over. I recommend these black things. Definitely not a stool. And if you do want to use one height as the black thing and one height as the counter, then that's okay. Just be careful and use the black thing to get up on the counter. And remember, slowly and carefully. It's not your maximum power, we're just calculating some power. Sound good? All right, please do the power lab.